Hi, thanks for stopping by. Around 11 years ago, I posted a not very notable YouTube video featuring this very same Yamaha XS650, albeit with a different petrol tank and colour scheme and probably one or two other things. As you see, I still have the bike, but even more remarkably, last week I had a new subscriber. Okay, that still only makes half a dozen after 11 years, so I may not be threatening the bigger channels, but it does still indicate that there's a fair interest in the old XS650 and working on old bikes in general. So I thought a follow-up video might be in order to really set the channel alight. The bike's always been maintained roadworthy, but I've generally not ridden her that much until this summer, when I've used her a lot, and she's actually gone really well. Until this week, when she developed a problem with the charging system, and you'll have to forgive the dodgy camera work, as I've only got the phone to work with and no tripod, and it's a pretty narrow garage to get round the bike. So the charging system developed a fault. Things started playing up just as I got close to home, like indicators stopped flashing, bit of a misfire, and to cut to the chase, we've identified that the bike is not charging at all. So let's get the saddle off, get the covers off, probably get in there with an Allen key and take the side cover off, and we'll just look at doing one or two checks. I've actually already identified the problem, but just for your information, I'll give you a little update there. So first port of call is whip the seat off and get access to the battery, and then you're going to need a multimeter. It doesn't need to be anything sophisticated. This one was a tenner from Screwfix, and set it to the 20 volts DC range. Put your probes across your battery. You'll be looking to see sort of 12.5 volts plus for a healthy battery, really. Anything below that means it's discharged. Mine's showing 12.65, which isn't awesome, but for a battery that's been in service for a while, several years, it's probably going to be as good as you're going to get. And then beyond that, fire the bike up, and you'll be looking to see a charging rate of sort of 13.5 volts upwards, really. You're not going to see much at idle, but if anything at all. But at 3,000 revs, then you should be wanting to see a healthy charge. But your upper limit's going to be 15.5 volts, but because beyond that you're going to be cooking the battery, and that's not good, obviously, and means your regulator rectifier is not doing its job. So I'm not going to be demonstrating that, because it'd be really noisy and defeat the object of videoing. You wouldn't hear me, and on a sort of small garage, and I'd probably gas myself as well. So next place to go is in here under this cover where your alternator is. Check out your rotor and your brushes. It's better to take that side cover off so you can see, but just quickly, I haven't done that because I wanted to show you this, which is the connector to the regulator rectifier. As you can see, it's had some issues in the past, although that's not looking like the problem today, but I think I possibly bypassed that burnt out connection here with a butt crimp. But anyway, we'll move on to getting this cover off and have a look in there. On second thoughts, there is a little bit more we can do before going in under the side cover. Right, wise precaution now it would be, as I've done, take your negative battery lead off while you're fiddling around with the wiring. Might save you some tears if you short something out. And coming back to these connections, despite appearances, this goes to the regulator rectifier, which is tucked down the back here, sort of just above the swinging arm. You can't hardly see it, but it's in there, that finned silver thing. But it is possible to test in here. So these white cables, which actually come via the harness down past your chain in behind this cover and into your alternator, you can probe in here with your multimeter, which in this instance I've set to the 200 ohms range, that being the lowest range, because what we're going to be talking about here are very low readings. And what we're going to do is check the continuity of the alternator, which would be the stator windings, which are the white cables. So I'm going to probe in here, and I've got something indicated by the beeping, so we're showing 0.5 it's settled at, which I think is a bit low according to the book, but bearing in mind this is only a £10 multimeter, you don't know how good the calibration is. What's going to be more important is that they're all similar, so you probe across all three. Right, not so easy to do one-handed holding the phone, but you check across all three. So you'd go middle to left side, middle to right side, and then left and right. And yeah, in this instance I've got 0.5 again, so I'm happy that they're consistent. And then the next check will be whether they actually short down to earth, because whilst we prove continuity, if you've got short down to earth, then nothing's going to happen, because it's just going to short any charge down to the ground. So then you'll be probing between these white wires and really a good earthing point on the chassis of your bike, so probably where your battery's attached on this terminal up here to the frame. So what you want to do is check that your windings are not shorting down to the chassis, engine chassis of the bike. So with the side cover removed and tied up out the way in my case, because I've got a hydraulic conversion and I don't want to disconnect the hose, the alternator is exposed. Here is your stator, windings are contained within that casing, and through the window you can see your rotor. You can test with your probes directly onto the tracks where these brushes run, if you're careful through there, but I've already identified a fault in my case with the rotor and also with the stator, and I'm going to remove the stator casing so I can get right in there and see if the fault is with the rotor and the stator themselves or with the wiring in between. So I'm going to remove this now and then we'll come back in. Here is the stator removed, hanging down here. You see the windings, and inside here, this is actually in my case, the pickup for the electronic ignition, and here are your brushes, so you get a good look at your brushes here. Okay, those are moving freely on their springs. You're a bit out of focus there, but there's plenty of meat on those brushes, so no problem there. Can't actually see any sign of burning or damage on the windings, which is a good sign, but I have already picked up a fault via the socket, the plug, so we're going to need to test that more on the bench, but I'm going to get it off to do that. Here's your rotor. You can test it by going across these copper tracks, if I can manage to do it one-handed. Again, meter on the ohms range, 200 ohms range. That's showing over limit or open circuit, but in my case, sadly, the shiny bits of the copper track are where the brush has been rubbing, but I've got my probes on those two shiny bits and there's no beeping. I'm still over limit because my rotor has for some reason gone open circuit. So that, I think, is our main problem. Taking off the pod filter up here exposes another multi-way connector. It didn't come off that easily. I've partially unplugged it for demonstration purposes, and that goes down to your generator. It's not going to threadle out where it's trapped behind these engine plates, so I'm going to have to take that off to release it, but that's going to release these cables coming down here to the stator. And then the next challenge after that will be to get this nut off, which ideally you'd use an impact driver for, only I don't have one here today, so I'm going to have to improvise, probably with putting the bike in gear, standing on the brake and using a breaker bar, and see if I can knock it off that way. A couple of weeks have elapsed since I've been able to get back to this job, but I do at least have the advantage today of having a tripod to hold the phone. So the stator's on the bench. Just to repeat the tests, this is the multi-way plug. You've got your 3 white wires coming from your windings in the stator. You're looking for continuity and similar readings between the 3 contacts, so testing left to centre, which again I'm getting 0.5, which is what I was looking for. That's what we got last time around. Left to right, 0.5, centre to right, again 0.5 ohms. So having proved we've got continuity between all of those, you can test from any one of those contacts, but it all amounts to the same thing in this instance, since they're all interlinked. To just check down to the casing of the stator and make sure that you have got an open circuit, so that is, you're not shorting down to ground, which indeed we have. There are 3 other wires on here. The green and the brown go to your brushes. We've already checked those out. I know we've got continuity, but just to recap, so green to brush, and also brown to the other brush. It's sprung, so it's a little bit awkward to keep the probe on there. So we're getting similar reading for each one, and it's a reasonably low resistance. We've got the resistance of the leads, the meter leads, so 0.3 of an ohms, quite acceptable. There's one further wire which is, well, or once was a yellow wire, pretty grubby. That is associated with the safety relay, which inhibits your starter. If you have that arrangement, inhibits your starter from operating when the engine's running, so there's a voltage appearing from the stator. I don't know any more about the workings of that. I'm not concerned with it because I don't have that safety relay currently operational on the bike in any case. So I'm going to move on. That's tested, all clear as far as my purposes. I did think there was a problem with it that I picked up when it was on the bike, but it's not showing any issues now, so I will recheck the actual harness of the bike again, because the plugs and socket arrangement for the regulator rectifier looks a bit iffy. I didn't have any success getting the rotor off of the bike using the standing on the brake with it in gear and trying to wrench it off. So I was hoping to get the rotor rewound, but instead I've gone for a replacement which I was able to get quite a good deal on. So let's take a look at that. Well, looks nice, new and shiny, and not unlike the sort of core of a nuclear bomb, I guess. Quite a weight to it. You've got the iron parts of it, plus what looks like quite a fair bit of copper in there. And I think that is the magnet that I will need for the pickup on the electronic ignition, which my bike has. Yeah, there's definitely a magnet, so we're looking good. Apart from, still got the issue of getting the old stator off of the bike. Rotor, I meant to say, which you can release this nut maybe by jamming something in the works to hold things, but that has the risk of, if it slips, you can damage something, and really impact driver is the only way forwards, which fortunately I have today. So I'm going to have a go at that, and as you can see, no problem. And then what's needed is your magneto flywheel puller, which I just happen to have to hand on this occasion. So we'll wind that on there. Back that centre bolt out a bit more. Okay, so wind it fully home. Swap out the socket for smaller. 16mm feels pretty good. Yep, 16mm it is. pops. Already determined this is not serviceable, or not currently serviceable, could be used as a candidate for being rewound. That looks like that might have the markings of having already come from some sort of salvage yard anyway, so it's probably had its time, and well, it's definitely had its time because it's not working. So the only way forwards would be to have that rewound, but we have a nice new shiny one to go in. So I'll probably crack on and reassemble things, as this is getting to be quite a long video. Back to the garage. It's a bit warmer in here. It's a pretty chill wind today, and that was a brief engine run, which accounts for the lumpy running of the bike. Somebody's bound to tell me that my valve clearances need doing, but it sounds a lot worse on the camera than it does in person, and I'd rather have my clearances a bit loose than a bit tight, that's for sure. So apologies for the schoolboy error part way through when I was testing on the bench and I had the camera in portrait mode. That didn't work so well, but I hope you got the gist of what was going on. We've seen 14.5 volts at 3000 revs, so I'm pretty happy with that after a fair amount of fiddling around and pretty messy routing the cable around where the chain runs and tidying up the wiring. But all in all, so I'll take that win. It's good to have the old bike charging up again, and thanks very much if you've stuck with me all the way through. I hope that was useful. Thanks a lot.